Guys, in today's video we are going to see one important topic again, echelon form. So when do we use this and why is this is using this echelon form we will find the rank of the matrix. Okay, but the question will be, if you listen to rank of matrix videos, there only we will find the rank of matrix by using the det, right? Simply. Then why do we need this is, this method is used to solve the complex matrices with more number of columns and rows. Also, this matrix is used to solve the algebraic expressions, like see generally how you will get the matrix like 1 2 3 4 5 6, so they'll give you this way. But there are some questions or some problems where you will get x plus y plus z equal to 2 and 2x plus 3y plus 4z equal to 1. So this is the matrix. You have to find the rank for this algebraic expressions. So how do you solve this? Means using this echelon form. So this is easy, but before solving this echelon form you have to understand row transformations as well. Okay, what is this row transformation? Generally you will not get any theoretical question related to the row transformation, so I'm not explaining you theoretically, but I'll just tell you how this is done and why. Okay, first let's see this echelon form, then I'll explain you the row transformations. So in this echelon form we have to, the main concept behind this is row transformations only. We will use completely row transformations to obtain the desired matrix. So remember that all these points, okay, remember these points, like if 0 rows means if any exists they should be below the non-zero. So all these points you'll understand when you solve the problems. For example, I'll explain all this in example. Say if you consider this matrix so here it is given that 0 rows means 0 rows. First, a matrix is said to be in echelon form, means when we say that particular matrix is in echelon form if 0 rows, that means no rows at all, or if there are any rows means they should be below the non-zero. That means non-zero means what? The value should not be equal to 0, right? So when you say that particular matrix is in the form of echelon form, means first you have to have some like non-zero rows, and then at last you should have all the 0 rows. Okay, this is the condition. Only the 0 rows must be at last only. After completing all the non-zero rows you should write the 0 rows. For example, if your matrix is not at all having the non-zero rows, that means completely zeros, so then it will be fine. You can write it as null matrix only, right? If there are any this kind of non-zero rows, means first you have to write them and then you have to write the zeros. But you will get a question like if the matrix is this way 1 2 3 0 0 0 4 5 6, so how you will write this 0? If you change the position, will that not be a problem? So here only we will use the row transformations. That's where row transformation concept comes in. Okay, I'll explain you that. So for now, this is the first point. Okay, now the first non-zero entry in each non-zero row is equal to 1, and remember that this is optional. Okay, this is not a mandatory condition. You should have, okay, you can have, not you should have, like see if the rows non-zero, if you have any non-zero rows, in that the first element should be 1. That means all the diagonal elements should be 1 and remaining you can have zeros. Okay, and while coming to the 0 rows which are at the bottom, they should not contain any ones. All those numbers should be zeros only. That's why this is optional. Okay, we don't concentrate on it much. And the third one is, the number of zeros before the first non-zero element in a row is less than the number of such zeros in the next row. That means, so if you take this matrix only, okay, what it is written 1 0 0 0 and so on, 0 0 and 0 0 0. So if you consider this way, first whatever the zeros we are starting, okay, here it should be only 1 0. For the next it should be 2 zeros. For the next it should be 3 zeros. That means no row, like you cannot have here 2 zeros, here 1 0, here 3 zeros. It should be in order. Okay, it should be in the increasing order as you go down. Okay, first whatever the non-zero row we are taking, okay, non-zero row means how you can say this non-zero row? If it is 1 0 0 0 1 2 0 0 1 0 0 0 0 0, Okay, this is a non-zero row, this is also a non-zero row, but the condition here is what? The number of zeros leading should be less than that of this row. Okay, that means you simply, in short, you can say that you should have upper triangle matrix or lower triangular matrix for the echelon form. Okay, mostly for the echelon form we use only the upper triangular matrix. There will be one more method. For that we will use both upper and lower triangular matrix. So this is a theoretical part of this echelon form. I know this is very confusing, but this is the most important topic in the rank of matrix. So mostly you will find the rank of matrix, find the what is the rank of matrix for the submatrix. You won't get those direct questions for this rank concept. So if you get, they'll be in a 2 marks or 3 marks. If the question is like 10 or 8 marks, something like, then you will get echelon form, canonical form, so those kind of questions. So remember that in echelon form all the zero rows should be at the last and non-zero rows should be in the first. Okay, and the number of zeros leading the non-zero rows should be in the increasing order. That means they will form an upper triangular matrix. This is the echelon form. And what are these row transformations means? We will change the rows. Okay, we will change the rows. That means we will take second row as third row as second row. Why? In order to get this format. You can't just directly get the format because you'll have numbers first, then you have to do by doing some simplifications you will just get this. How you will do simplification? Now the basic concept we all know is LCM, right? So 1 by 6 plus 3 by 2 we have. So here we will get the LCM for 6 and 2 as 6. Now what are we doing here? We will multiply both numerator and denominator with 3 to get the LCM as 6. The same concept we will use here also. For example, if we are having here 2 0 2 and 5 0 7 and 3 0 0. Okay, now our aim is what? We have to make these positions as 0 only, right, to get the echelon form. Now I will do, what I will do is, first I will multiply this complete row with 3 and this complete row with 5. Then you will get 15 15 right here, both the positions. Then I will subtract row 2 minus row 3. Okay, then value will be 0, right? So such way, those are row transformations. Okay, same like LCM, how we will make all the denominators equal. Here also we will make sure that we will multiply with a number for the entire row, and then we will make sure that all the elements in that particular row will be 0 for the last rows. Okay, this is how you will develop this, like which row I have to transform now, which element I should multiply, which number I have to take. So for all these you have to do is practice. Okay, I'll explain you with the help of a few problems, then you can understand it very clearly. So I'll make a video on those problems soon. And for this also we have different types, like they'll give you a matrix directly and then they'll ask you to find rank of matrix using echelon form, or they'll give you algebraic expressions and then they will ask you to find the rank of the matrix. So I'll explain all the methods whatever there in the rank of matrix concept. Okay, thank you.